Humans have lived off Earth continuously since 2000, and the largest space station ever built spans wider than a football field while circling the planet about every 90 minutes. In this video we cover Salyut Stations, Skylab, Mir, International Space Station, Tiangong Space Station, and commercial space stations in development. If you want every major type broken down in one place, subscribe. We do this for everything. The Salyut Stations were the world's first true space stations, launched by the Soviet Union starting in 1971. They were basically small, orbiting laboratories where crews arrived in separate spacecraft, lived for weeks or months, ran experiments, and then returned home. Power came from solar panels, air and water were stored and recycled in limited ways, and ground teams constantly monitored life support. Some Salyuts were civilian science labs, while others were secretly tied to military observation. One Salyut mission set a new endurance record for living in space, proving people could stay aloft far longer than anyone expected. That opened the door to America's first station. Skylab was the first American space station, launched in 1973, from hardware originally meant for the Apollo moon program. It worked like an orbiting workshop, with astronauts docking in Apollo spacecraft, using solar power, and living inside a much roomier interior than earlier stations offered. They studied the sun, watched Earth, and learned how the human body changed during long missions. Right after launch, Skylab was badly damaged when a shield tore away, but astronauts repaired it in orbit, turning a near failure into a success. Its uncontrolled re-entry scattered debris over Australia in 1979, leading naturally to the next era of longer-lived stations. Mir, launched by the Soviet Union in 1986 and later operated by Russia, was the first modular space station, meaning it grew piece by piece in orbit. Instead of one single can, new sections were added over time, creating a larger home and laboratory for crews. Solar arrays supplied electricity, docked cargo ships brought food and fuel, and visiting spacecraft rotated astronauts in and out. Mir hosted international crews and became a testbed for the kind of long missions needed for future deep space travel. It also survived a serious fire and a collision with a cargo craft, showing both the risks and resilience of living in orbit. That modular idea reached its biggest form next. The International Space Station, or ISS, is the largest and most complex space station ever built, assembled in orbit from 1998 onward by the United States, Russia, Europe, Japan, and Canada. It works like a flying research campus, with linked modules for sleeping, science, exercise, storage, and control, all powered by giant solar arrays. Crews and cargo arrive on different spacecraft, while life support systems clean air, recycle water, and help keep people alive for months at a time. More than 270 people from many countries have visited, and astronauts have even grown plants there. As the ISS ages toward retirement, another national station has already taken center stage. Tiangong is China's permanently crewed space station, built in its current 3-module form between 2021 and 2022. It works much like a smaller modern research outpost, with a central core for control and living space, plus lab modules for science, exercise, and equipment. Solar panels provide power, robotic systems help with operations, and Shenzhou cruise ships and Tianzhou cargo ships keep it supplied. Astronauts there study medicine, physics, and how materials behave in microgravity, while also doing spacewalks to maintain and expand the station's capabilities. Tiangong can host short-term increases in crew size during handovers, and it points toward a future where stations may be run by many different groups, not just governments. Commercial space stations are the next major category. Privately operated outposts now being designed by companies, often with support from national space agencies. Instead of one government owning the whole station, these platforms are meant to host research, manufacturing, astronaut training, and even private visitors who pay to fly. Most plans use modular sections launched separately, then connected in orbit, with power from solar arrays and resupply from reusable spacecraft. Projects like Axiom Station, Starlab, Orbital Reef, and Vast's Haven concepts aim to replace some of the ISS's jobs after it retires. If they succeed, low Earth orbit could shift from a few flagship stations to a busy neighborhood in space.